Okay, so I'm going to just run through some of the basics of electrical circuits here as a bit of a refresh type thing. So here we've got a certain EMF being given to the circuit. That's 30 volts up here. Now you may remember that this is what's called a parallel circuit, and that is where it forms effectively two circuits which are kind of separate from each other in some way. So we've got one circuit up here and another circuit down here. So this forms a circuit and this forms a circuit. It's kind of two circuits in parallel to each other. What we also hopefully remember from GCSE is if there's a 30 volt supply up here, that means the potential difference across each of the branches is also going to be 30 volts. Okay, now here in this branch there's only one component, so each of those gets a full 30 volts. If I add another branch onto that, let's say a resistor, we'll just say two identical resistors here, that means that each of those will have 15 volts, okay, because these two are in series to each other. But of course the combined potential difference for those two is going to be 30 volts, of course, right, because it's a parallel circuit. Other things we could maybe say is, well, we know that the current goes out from here, reaches this point, some of it goes this way, some of it goes that way, and some of it goes this way. So the current goes off these three different ways. So this current, for example, goes up here and comes back into this junction here. This current goes right the way through and comes back at this junction here. So these two together are coming in here, which will also then meet this one up here. So they come together into this. And the point is that this leaves here, goes these three different ways, but they rejoin all together. So that the current, for example, here will be the same as the current here. Okay? So these two will be the same. So those are some of the fundamental laws that we deal with. We're going to look at those in some more detail later in this topic. But those are some things we really want to keep in mind when we talk about this stuff. And if we want to do some calculations, for example, we want to relate resistances. Well, we know, for example, well, let's just say that this is Z or Z ohms. And so is this one. That means the total resistance here, whoops, sorry, I'm out of shot. The total resistance here will be 2Z ohms. Okay, and if we wanted to get the entire resistance for the whole network, well, actually it'd be fairly easy, because what we could do, for example, is read this current up here and then just do R equals V over I. Likewise, so that would get us, so we would just solve with V and just read off this. We would solve for R. What we could do then is also we could find the resistance of this by taking this and dividing by whatever rate for the current, and likewise here and so on. Okay, but of course the other way of getting resistance in a parallel circuit is, well, if we want the total resistance, we do 1 over the total resistance is equal to 1 over R1 plus 1 over R2 and so on, bearing in mind that we have to treat this as one resistor then when we're doing this calculation. Okay, so yeah, because that's within a whole branch of that network. So those are the basics of things that we might want to work with. Not so much in what we're doing today, but those are some of the basics which will be useful to you.